In this video, we're going to look at part 2 of our calculating missing angles. Now you can see that we have our vertically opposite X shape, which we encountered at the end of the last video, but we also have corresponding angles which are in an F shape and alternate angles which are in a Z shape. The F and Z shapes are as a result of a transversal line, so the diagonal crossing two other lines that don't cross, so in this case they are parallel. Now our corresponding angle, you can see that we've got two triangles showing the equal angles in our F. So the triangles marked are corresponding angles. Now we can put the F onto our transversal line backwards. We could put the F on upside down, or we can put the F on backwards and upside down, but the corresponding angles are in the same place on the F. With our alternate angles, we have a Z shape, and it can be forwards or backwards, and so the squares in the picture shown are equal alternate angles. So in this example, we're going to find the missing angle, and firstly, we're going to use the complementary angle method, which is our F-shape angle. So we're looking for an F shape that includes that 32 degrees. And you can see if we draw in our green highlighted F, the angle at the top is 32 degrees because our F is backwards and upside down. So we can say that X is a straight line, or is the supplement of that 32-degree angle. So we can calculate X by taking 32 away from 180. So 180 take away 32, and that gives us an angle of 148 degrees. Now we're going to look at the same example, but this time we're going to use the Z shape, the alternate angle method. And this time we're calculating angle DCF instead, and that's going to be 32 degrees. And so now angle ACF or ACH is going to be 180 degrees. So X is the supplement of our 32-degree angle. So again, we're just going to do 180 take away 32, and our angle is still 148 degrees. Now, angles in a triangle always add to 180 degrees. And you can see the proof of this in this diagram. Because if we put on our alternate angles, so our Z-shaped angles, you can see that angle A inside and angle C inside the triangle will form a straight line at the top of the Zs. So we want to find the missing angle in this triangle. We know that the square at the vertex on the left-hand side means that this angle is 90 degrees. And then we want to add the known angles together. So we're going to do 90 plus 52, and that equals 142 degrees. And then we can work out the missing angle by taking that 142 away from 180. And 180 take away 142 gives us a missing angle of 38 degrees. Our next example, we're finding missing angles in an isosceles triangle. So our base angles are equal because we've got two equal sides. So D plus E is going to equal 180 take away 50, and that gives us 130 degrees. Now we know that D equals E, and so we need to split it in half, and so 130 divided by 2 is going to give us a value of 65 degrees for both. Now, angles in a quadrilateral always add up to 360 degrees. In the parallelogram shown on the screen, you can see that diagonal DB has been put in a dashed line, splitting our parallelogram up into two triangles. We've got triangle ADB at the top, and then we've got triangle BCD at the bottom. Now we know that the angles in one triangle add up to 180 degrees. So if we've got two triangles, then it makes sense that we're going to have double the value of one triangle, so 180 times 2, which equals 360 degrees. And so you can see we've got a square, which is obviously four 90-degree angles, adding up to 360, but any quadrilateral, the four interior angles will add to 360. So in this example, we want to find the missing angle x at angle DAB. And the first thing we're going to do is add all of our known angles together. So 56 plus 64 plus 110, and that equals 230 degrees. And then we know that it's a quadrilateral, so x is going to be 360, take away 230. So x equals 130 degrees.